The project began in a cluttered basement workshop, fueled by the obsessive ambition of lead engineer Elias. Elias Thorne sought to shrink a high-performance PC into a chassis no larger than a playing card. The core challenge was not just the miniaturization of components, but the brutal reality of thermodynamics. A processor of this caliber would typically melt its own housing within minutes without massive heat sinks. Elias spent months sourcing custom-milled copper vapor chambers to manage the intense heat of the tiny core. He experimented with liquid metal thermal interfaces, pushing the boundaries of what was physically possible for hardware. Every millimeter of space was accounted for, with custom-printed circuit boards stacked like a miniature city. These circuit boards were layered with extreme precision, forming a skyscraper of silicon in a small space. The air in the basement felt heavy with the scent of ozone and the weight of expectation. As the final power delivery module was soldered into place, the tension in the room was palpable. His hands remained steady despite the exhaustion that had settled into his bones over many sleepless nights. The device sat on the workbench, a silent, obsidian cube that represented the pinnacle of microengineering. It was a dark, unassuming monolith waiting to see if it could survive the initial boot sequence. Elias wiped a bead of sweat from his brow, his eyes locked onto the small, dark object. He knew that one wrong connection would result in a catastrophic failure of the entire internal system. The silence of the basement was absolute, broken only by the faint, rhythmic sound of his breathing. He reached for the power cable, his fingers trembling slightly as he prepared to initiate the test. The copper vapor chambers were perfectly aligned, designed to wick away heat from the central processing unit. He had calculated every thermal path, ensuring that the heat would dissipate across the entire metal chassis. The liquid metal interface was applied with microscopic accuracy to bridge the gap between chip and cooler. If his calculations were correct, the obsidian cube would remain cool even under the heaviest of loads. If he were wrong, the delicate circuits would fuse together in a flash of sparks and smoke. He checked the connections one last time, verifying the integrity of the power delivery module's tiny pins. The workbench was littered with discarded prototypes, each one a lesson learned in the pursuit of perfection. This final iteration was the culmination of his life's work, a singular focus on absolute hardware density. He took a deep breath, steadying his nerves before making the final connection to the power source. The obsidian cube sat waiting, a dormant titan of silicon ready to wake from its long slumber. Elias felt the weight of his ambition pressing down on him, a heavy mantle of engineering pride. He adjusted his glasses, peering closely at the intricate assembly he had spent months crafting by hand. The basement lights flickered, casting long shadows across the walls as he prepared for the final moment. He carefully aligned the gold-plated pins, ensuring each contact point met its destination with absolute, surgical precision. A single stray fiber of dust could bridge a connection and destroy the entire delicate logic board. He held his breath, his heart hammering against his ribs like a trapped bird in a cage. The power supply hummed with a low, electric vibration that seemed to resonate through the wooden table. He pushed the connector home, feeling the satisfying click of metal locking firmly into its intended place. For a heartbeat, nothing happened, and the silence in the room became heavy and suffocatingly thick. Then, a tiny sapphire blue LED flickered to life, casting a ghostly glow across his tired, pale face. The light pulsed steadily, signaling that the power delivery system was successfully managing the initial electrical surge. Elias exhaled a long, shaky breath, his shoulders dropping as the immediate fear of a short circuit faded. He monitored the diagnostic screen, watching as lines of code scrolled past at a rapid, dizzying pace. The processor was initializing, its internal clock speed climbing steadily toward the target frequency he had set. He watched the temperature sensors, waiting for the inevitable spike that would indicate a failure of cooling. The numbers remained low, a testament to the efficiency of the copper vapor chambers he had meticulously installed. The obsidian cube sat silently, yet inside, billions of transistors were firing in a complex, synchronized dance. He felt a surge of triumph, though he forced himself to remain focused on the remaining diagnostic tests. The software environment loaded, revealing a crisp, high-resolution interface on the small, connected external monitor screen. It was working, a fully functional computer contained within a space no larger than a deck of cards. He navigated the menus, testing the responsiveness of the system under the strain of multiple background processes. Everything moved with fluid grace, defying the physical constraints he had fought so hard to overcome today. The cooling system hummed softly, a nearly imperceptible sound that promised stability during the intensive gaming tests. He prepared to launch the stress test, the ultimate trial for his tiny, high-performance silicon masterpiece. His fingers hovered over the keyboard, ready to push the hardware to its absolute, theoretical thermal limit. The room felt colder now, or perhaps it was just the adrenaline finally leaving his exhausted, weary body. He clicked the icon, watching as the screen filled with complex geometry and high-fidelity, rendered lighting effects. The obsidian cube began to warm, the metal chassis absorbing the heat generated by the intense workload. He watched the thermal graph, seeing the temperature rise and then plateau exactly where he had predicted. The cooling solution was holding, effectively wicking the heat away from the core into the surrounding air. A smile tugged at the corners of his mouth, a rare expression of satisfaction after so many months. He had done it, proving that even the most rigid laws of physics could be bent with ingenuity. The tiny machine continued to run, a silent, powerful testament to his unwavering, singular vision of progress. With a steady hand, Elias connected the power supply to the obsidian cube on his workbench. He held his breath as the tiny internal fan spun to life with a high-pitched hum. The sound was a harmonic vibration that resonated through the quiet, cluttered basement workshop air. Suddenly, the monitor flickered to life, displaying the complex lines of the BIOS interface. This confirmed that his impossible architecture was indeed fully operational and ready for the test. However, the true challenge arrived when he launched a resource-heavy simulation to test the limits. He pushed the GPU to its absolute limit, demanding peak performance from the tiny, dense components. The casing grew warm under his fingertips, but the innovative cooling array held remarkably steady. It dissipated heat through the chassis itself, in a true masterclass of advanced thermal management. The system remained stable, effectively defying the skeptics who claimed such power was a disaster. They had insisted that such extreme power density was simply a recipe for inevitable failure. Yet, the machine continued to function perfectly, maintaining its cool despite the heavy processing load. As the game rendered flawlessly on the screen, Elias felt a surge of immense pride. He realized he had not just built a computer, he had rewritten the rules entirely. The pocket-sized machine hummed contentedly, a testament to the power of his own human ingenuity. It was a triumph of overcoming the rigid, unforgiving laws of physics through sheer design. Every circuit, every solder joint, and every thermal interface had performed exactly as he intended. The obsidian cube sat there, a silent sentinel of progress in the dim basement light. He watched the frame rates climb higher, far exceeding the performance of traditional, bulky desktop towers. The cooling system continued to cycle heat away from the core with quiet, efficient grace. Elias leaned back in his chair, finally allowing himself to exhale the tension he held. The months of sleepless nights and meticulous planning had finally culminated in this singular moment. He reached out to touch the chassis, feeling the gentle warmth of the working processor. It was not burning, nor was it failing. It was simply working exactly as designed. The simulation continued to run, pushing pixels with a speed that felt almost supernatural today. He had pushed the boundaries of what was physically possible, and he had finally won. The miniature city of circuit boards inside the cube remained perfectly aligned and fully functional. He knew that this device would change everything for the future of portable computing technology. The skeptics would have to rethink their assumptions about thermodynamics and miniaturized high-performance hardware. Elias watched the screen, mesmerized by the fluid motion of the graphics rendering so smoothly. There were no stutters, no crashes, and no signs of the thermal throttling he feared. The vapor chambers were doing their job, pulling heat away from the silicon with precision. He felt a deep sense of satisfaction wash over him as the test continued onward. The basement felt smaller now, filled with the presence of his successful, tiny, powerful creation. He had taken the brutal reality of thermodynamics and forced it to bend to him. It was a victory of unrelenting design precision over the limitations of standard engineering practices. The obsidian cube was a beacon of what could be achieved through pure, obsessive ambition. He looked at his hands, steady once more, and then back at the glowing screen. The simulation reached its conclusion, and the system returned to its idle harmonic hum state. He had proven that the impossible was merely a challenge waiting for the right mind. The project was a success, and the world of portable hardware would never be same. He turned off the monitor, letting the silence return to the basement workshop once again. The cube remained warm, a small glowing ember of innovation resting on the wooden table. Elias stood up, his legs stiff from hours of sitting in the same cramped position. He walked to the small basement window, watching the world outside continue its slow pace. They had no idea that a revolution in computing had just occurred in this room. He returned to the bench and carefully disconnected the power supply from the small device. The hum faded away, leaving the room in a heavy, expectant silence of quiet accomplishment. He picked up the obsidian cube, marveling at its weight and its incredible dense complexity. It was the pinnacle of his life's work, a masterpiece of microengineering and thermal physics. He placed it into a protective case, treating it with the reverence of a relic. The journey had been long, but the destination was worth every single moment of struggle. He looked around the cluttered workshop, seeing the tools that had helped him build it. Every scrap of copper and every discarded component told a story of his persistent effort. He had pushed the boundaries of physical possibility and emerged on the other side victorious. The Silicon Microtitan was real, and it was ready to change the world forever now. He turned off the main workshop lights, leaving the room in a soft, dark shadow. The only thing left was the faint, lingering heat of the machine on his palm. Elias smiled in the dark, knowing that the future of technology was in his hands. He walked out of the basement, leaving the small, powerful cube to rest in peace.